Imagine a time, before stars, before light, before anything you know. Imagine all the stuff that makes up everything. Every planet, every star, every galaxy, every single person squeezed into a space smaller than a grain of sand. This tiny, hot, and incredibly dense point held the promise of our entire cosmos. It was a universe waiting to happen, a story waiting to be told. All the laws of physics, all the energy, all the potential for life and consciousness, it was the ultimate beginning, poised on the brink of an unimaginable expansion. Then it happened. In a flash, the universe burst into existence. We call it the Big Bang, not an explosion in space like a firecracker, the explosion of space itself. Space began to expand everywhere, all at once. The young universe was vast, dark, mostly empty, but it wasn't perfectly uniform. Tiny, almost imperceptible fluctuations in the density of matter were scattered throughout space. These were the seeds of structure. Gravity, the quiet and persistent force of the cosmos, went to work. In the slightly denser regions, gravity began to pull the abundant hydrogen gas, helium gas, into ever larger clouds. Over millions of years, these clouds grew more and more massive, like cosmic snowballs rolling downhill. It was a slow, patient process, a cosmic dance choreographed by the fundamental laws of nature, pulling matter together to build the first great structures. As these gas clouds collapsed under their own gravity, the pressure and temperature at their centers skyrocketed. The cores became so hot and so dense that something miraculous happened. Nuclear fusion ignited. Hydrogen atoms were smashed together to form helium, releasing a tremendous amount of energy in the process. A star was born. About 9 billion years after the Big Bang, in a quiet, unassuming spiral arm of the Milky Way galaxy, a new story began. A giant cloud of interstellar gas and dust, enriched by the ashes of long-dead stars, started to collapse under its own gravity. Perhaps the shockwave from a nearby supernova gave it the push it needed. As this cloud, our solar nebula, spun faster and faster, it flattened into a disk, like a spinning pizza dough. At the center, where most of the material gathered, the pressure and temperature soared, a new star was igniting. This star was our sun, a second or third generation star, born from the recycled stardust of the cosmos. The rest of the spinning disk didn't fall into the sun. Instead, it began to clump together. Tiny grains of dust and ice stuck to one another through static electricity pebbles. Boulders, planetesimals, the small rocky seeds of planets. It was a messy, chaotic construction zone. These planetesimals collided and merged, growing larger through a process called accretion. For millions of years, our young solar system was a cosmic demolition derby, with countless small bodies crashing into each other. In this cosmic mosh pit, a few large bodies emerged as the winners. Among them, in the third orbit from the Sun, was a young planet we call Earth. It was not the gentle blue world we know today. It was a molten ball of rock, constantly bombarded by asteroids and comets left over from the solar system's formation. This period, known as the Hadean Eon, was a hellish time. The surface was a glowing red-hot ocean of magma. But even in this inferno, our planet was assembling itself. Heavier elements like iron-nickel sank toward the center to form the core, creating a magnetic field that would one day protect us from harmful solar radiation. One of the most significant events in Earth's youth was a colossal impact. A Mars-sized object, which we've named Theia, collided with the young Earth. The impact was cataclysmic, vaporizing both bodies and throwing a vast amount of molten rock and debris into orbit. This ring of debris eventually coalesced to form our moon. This violent birth had a profound consequence. The moon's gravity stabilizes Earth's tilt, giving us the predictable seasons that have been so crucial for the evolution of life. Our planet was being shaped piece by cosmic chance and the unyielding laws of physics, preparing it for the next chapter in its extraordinary story. After the fiery chaos of its birth, the Earth began a long process of cooling. Over millions of years, the molten magma on the surface slowly solidified into a dark, rocky crust. But the planet was still a dynamic place. Volcanoes erupted constantly, spewing gases from the planet's interior. This outgassing created Earth's first atmosphere, a thick blanket of water vapor, carbon dioxide, nitrogen, very different from the air we breathe today. The planet was shrouded in clouds, a steamy, volcanic world waiting for the next great transformation. The stage was being set, the raw materials for a living world were now in place. As the planet cooled further, a magical threshold was crossed. The temperature of the atmosphere dropped enough for the water vapor to condense into liquid. And then, it began to rain. Not for a day or a week, but for millions of years. This was the greatest deluge the world has ever known. Water poured from the skies, filling the low-lying basins, filling craters, forming the first oceans. Comets, asteroids, rich in ice, also crashed into Earth during this time, contributing even more water to our young world. Slowly, relentlessly, our planet transformed from a red-hot rock into a blue marble, a water world. Beneath the waves of these primeval oceans, something even more remarkable was about to happen. The oceans were not just pure water. They were a rich chemical soup. Dissolved minerals from the crust. Complex organic molecules formed by lightning strikes in the atmosphere. In this primordial soup, perhaps near superheated hydrothermal vents on the ocean floor, the building blocks of life, amino acids, nucleotides, began to link together in ever more complex chains. It was a cosmic lottery with an incredible jackpot. The non-living was on the verge of becoming the living. And then, it happened. We don't know exactly how or when, but at some point, a collection of molecules crossed a monumental threshold. It developed the ability to harness energy from its surroundings and, most importantly, to make copies of itself. This was the first life. These were not plants, animals, but simple, single-celled organisms, far smaller than a grain of sand. They were the last universal common ancestor for every living thing that has ever existed on Earth, including you. From this one microscopic spark, the entire tree of life would eventually grow, a testament to the creative power of the cosmos. For billions of years, life remained simple. The oceans teemed with microscopic bacteria and archaea. One group, the cyanobacteria, figured out a revolutionary new way to make food: photosynthesis. They used sunlight to convert carbon dioxide into energy. They used water to convert into energy. As a byproduct, they released oxygen. This was a game changer. Slowly, over eons, oxygen accumulated in the atmosphere, transforming our planet. It was toxic to much of early life, causing a mass extinction. But it also created conditions for a new, more energetic life. Life that could breathe. The stage was set for the Cambrian explosion about 540 million years ago. In a short burst of geologic time, the oceans erupted with diverse, complex animals. For the first time, we see creatures with shells, skeletons, legs, eyes. The microscopic world gave way to visible, active animals. Life was not content to stay in the oceans. Over millions of years, plants began to colonize the barren land, turning the rocky continents green. They were followed by small invertebrates like insects, then by the first vertebrates to brave the shore, amphibians. These creatures, evolving from lobe-finned fish, still needed to return to the water to lay their eggs. But soon, reptiles evolved a major innovation: the amniotic egg. This self-contained private pond allowed them to lay their eggs on dry land, freeing them from the water and allowing them to conquer the continents. The world was now open for a new dynasty of rulers. This new dynasty was the dinosaurs. They first appeared around 230 million years ago and came to dominate the planet in a way no other land animals have. The end of the dinosaurs was a tragedy, but it was also, an opportunity. For over 150 million years, another group of animals had been living in the shadows of the giant reptiles. These were the mammals. During the age of dinosaurs, they were mostly small, nocturnal, shrew-like creatures scurrying through the undergrowth, hunting for insects at night to avoid becoming a meal themselves. They survived the Great Extinction event perhaps because their small size meant they needed less food, or because their burrowing and warm-blooded nature helped them endure the cold and dark of the impact winter. With the dinosaurs gone, a vast ecological void was left, and the mammals were perfectly poised to fill it. They stepped out of the shadows and into the sunlight. What followed was an explosion of mammalian evolution. They diversified rapidly. Some returned to the water, others took to the trees on the plains. Giant herbivores like the Indricotherium emerged, while fearsome predators like the saber-toothed cats became the new top carnivores. The world continued to change. The continents drifted further apart and the climate cooled, forming polar ice caps in the start of the ice ages. From these early upright ancestors, a new species emerged on the African savanna: Homo habilis, the handyman. About 2.5 million years ago, they began to do something no creature had ever done before. They intentionally chipped stones to create sharp edges. These were the first tools. They might seem simple to us, but they were a profound leap forward. Tools let them butcher carcasses left by predators. They scraped meat off bones. They cracked bones open for marrow. That new protein and fat helped fuel growing, energy-hungry brains. Next came Homo erectus, the upright man. taller with larger brains, the first to leave Africa, spreading into Asia and into Europe. They harnessed a force that changed our destiny: fire. Maybe at first they tended fires started by lightning, then they learned to make and control fire themselves. Fire gave warmth for colder climates, it provided protection from nocturnal predators. It revolutionized diet. Cooking made food easier to digest. Cooking unlocked more nutrients, fueling brain growth. The campfire became the first living room, extending the day with light. For most of our history, Homo sapiens lived as nomadic hunter-gatherers moving with the seasons following the herds. But about 10,000 years ago, in several places around the world, we began to experiment with a revolutionary new idea. We learned to cultivate plants, domesticate animals. This was the agricultural revolution. Instead of searching for food, we could grow it. This allowed us to settle down in one place. Small villages grew into the first towns, then into the first great cities. Mesopotamia, Egypt, Indus Valley civilization was born. With a stable food supply, not everyone had to be a farmer. People could specialize in other crafts. Weaving, metalworking, building. To keep track of grain harvests and trade, a powerful new tool was invented: writing.